Hello everyone, welcome to another video session class. So in today's class we will study about the oxazole aromaticity and its synthesis or preparation. Okay, so oxazole is a from the name we can say oxa and azole. Okay, oxa and azole, that means oxa means oxygen, aza means nitrogen. So it is a 5-member ring containing heterocyclic compound where oxygen and nitrogen are present. So from the name we can get the idea it is oxa and azole. Okay, ox from oxygen, az for aza, nitrogen. Okay, so let us just start. This is the structure of oxazole. You just see here is oxygen and nitrogen present. Okay, so that's why it is known as oxazole. So the nitrogen is acting as a pyridine like nitrogen, and oxygen, we know furan is containing oxygen, so it is furan like oxygen is present. Okay, so about its aromaticity, oxazole have 3 carbons. So here 1 2 3 carbon, 1 nitrogen and 1 oxygen. So 1 oxygen, all are sp2 hybridized. Okay, sp2 hybridization is planar. We know the molecule formed by this sp2 hybridized are planar, that is hybridized orbital structure is planar, so it makes a planar oxazole ring structure. Okay, each ring atoms also contains unhybridized p orbital that is perpendicular to the plane of sigma bond or single bond. Okay, that is plane of ring. So this p orbital are perpendicular to the plane of ring. Okay, here p orbitals are parallel to each other, so we know these p orbitals are always parallel to each other, and which lateral overlapping of these p orbitals give rise to the double bonds. Okay, correct. The total number of non-bonding electrons are 6, 3 of 3 carbon, 1 from nitrogen, so 1 from nitrogen and 2 of oxygen. So total number of non-bonding electrons are 6. So it follows Huckel rule. However, an oxygen atom is highly electronegative, so the delocalization is not overly effective. Okay, so delocalization takes place, but it is not overly effective because of highly electronegativity of oxygen. Okay, so next, synthesis. So first synthesis, it is Robinson-Gabriel synthesis. Okay, here cyclizing dehydration take place. That means within the molecule, okay, intramolecular cyclization take place, acid catalyzed cyclization or closure of an alpha acyl amino carbonyl compound. So it is alpha acyl. Okay, alpha acyl, this is alpha acyl, then amino acyl amino. Okay, amino carbonyl compound, so this is carbonyl group, C double bond O. Okay, alpha acyl amino carbonyl compound, so in alpha position carbonyl group is there, so it is alpha acyl amino carbonyl compound. Okay, so if you just do H plus, there is protonation in acid catalyzed reaction, water will come out from this one and it will give the compound what? Oxazole. Okay, so let us see the mechanism of this reaction. So here protonation will take place first to this oxygen of carbonyl carbon. Okay, carbon compound, you see this one. Okay, C double bond O, carbonyl group. So here this is, so here the H proton will attack, that means oxygen is electronegative, so H plus will attack, so it will give OH. Okay, so oxygen will attain positive charge. Next, what will happen? Cyclization take place. This hydrogen will break down, hydrogen will come out, and it will, this electron pair will shift to this place. Okay, so there will be formation of one double bond, and this oxygen one bond will break down and it will attack this carbon. Okay, earlier it was carbonyl carbon, so oxygen and this carbon bond will form. Okay, and here OH is there and this is R3. Okay, so here you see this is the reaction. So after coming this lone pair of electron from nitrogen, nitrogen will attain one positive charge. Okay, so next this hydrogen will come out and this OH will come out to form a bond here. Okay, so ultimately HOH, so there will be dehydration, water will come out and this nitrogen is positive. So ultimately in the first step one protonation take place, so in the last step again this proton will be removed by deprotonation. So after deprotonation, nitrogen will again attain its neutral state. Okay, so this is the product Oxazole. So next, another method of preparation, that is from alpha hydroxy carbonyl component. So you see it is alpha hydroxy, this is alpha position from this carbonyl carbon. So alpha hydroxy, OH means hydroxy ketone, so overall this is ketone, and along with amide it will 2 molecule of water will go and it will condense to give the substituted oxazole. So example, you see this is alpha hydroxy ketosuccinate, then formamide, it will just 2 molecule of water will come out and it will form this one. Okay, diethyl oxazole 4,5 dicarboxylate. So this is dicarboxylate, again ester hydrolysis in presence of barium hydroxide, so C2H5 will come out, so oxazole 4,5 dicarboxylate. And again, if you just, this is also oxazole, but to remove the other groups, you just, in presence of quinoline and copper as a catalyst, decarboxylation will take place, that is 2 CO2 will come out and it will form ultimately our structure, desired structure, that is oxazole. So next, from isocyanide, so you see reaction of isocyanide with acid chloride or acid chloride or anhydride or acid anhydride yields substituted oxazole. So you just see it is isocyanomethyl benzene, 1 carbon, so methyl, and acetyl chloride, it will react in presence of n-butyl lithium, that is butyl lithium, so it will form 5-methyl 4-phenyl oxazole. So you just see C6H5, this your carbon, this carbon, then N, then again C, then this C is connected to this oxygen, and chlorine came out. Okay, chlorine came out, so ultimately you are getting 5-methyl 4-phenyl oxazole compound. Okay, then next, the reaction of an acid imide and alpha halogen ketone yields oxazole. So here it is another method of preparation. So reaction of acid imide, so you just see this one is acid imide. Why it is imide? Because C double bond and bond is there. So here, from here HBr will come out. So what will happen? You just see NH, CNH, OH, okay, HBr will come out. Okay, H and Br will come out. So O C2, this CH2. Okay, this is CH2. Then again C double bond O, then this undergoes cyclization to form this benzene. Okay, then again this will go cyclization, here C and N will connected. Okay, C and N will be connected, this H will shifted to this oxygen. So you just see from H, from here it will shift to this oxygen to form OH. So this is the compound. Next, after that one, what will happen? One water molecule will come out. Okay, so OH, then from here one H, OH, and from here one H, so water will come out to give the substituted oxazole. Okay, so this is all about the preparation and aromaticity. I hope you understood. Thank you.